Okay, so we are going to talk about least squares. So least square problem is, suppose you have a lot of data, okay? So in this case, we have like 7 data points. So like the value when time equals 0, time equals 0.5, and so on up to time equals 3. And you see the values of the data are the red dots, yeah? And now we try to fit a line that through the data. So you see, like for 2 points, then there's only one line that go to 2 points. But now we have like 7 points. So, you know, there is no lines that go through 7 points unless they're on the same line. But, you know, here those points are not on the same line. So now, which one is the best line? So in order to find out the best approximation, you have to consider the residual. So residual is, you know, the difference between the data and the point on the line. So suppose R1. So R1 is, you know, the value at the point T1 minus the data point. And you try to minimize the square of the residual. Okay? And when you minimize this one, then it's become a least square problem. So the line will fit the data in the sense that it minimizes the least square residual. And the residual is defined like this. So how do we set up the problem? So first, you know, in this problem, we have to write down the coefficient matrix first. And so first we have to write down what is the residual. So residual, suppose you have R1, then this one is just YT1 minus Y1, okay? And YT1, you just replace by this equation. So you have alpha plus beta T1 minus Y1, okay? And then you write out R2 is YT2 minus Y2 is alpha plus beta T2 minus Y2, and so on. So you have up to R7, okay, is YT7 minus Y7 is alpha plus beta T7 minus Y7. And you can see that this one, when you write down in terms of a matrix, yeah, so it could be, you can write out as a vector. First, the residual vectors is a column vectors. So R1, R2 up to R7. Okay. And then, so this is a column vector residual. And then these equations can be written as, you know, I mean, you write down the unknown coefficient alpha and beta here. Then this one is just 1 T1, yeah. So the 2 columns, 1 alpha plus T1 beta, and then 1 T2, and so on. Up to the last one is 1 T7. And so this part capture the this 2 columns, and then minus Y1, Y2 up to Y7. Okay. And you can see that this one, we can label this one as a matrix A. And this one you can relabel as a vector X. And this one minus, so this is a multiply, so you can multiply A with X minus Y, okay? And this is a residual vector, so R is a residual vectors. So essentially we have identified the coefficient matrix of the least square problem. So this is a coefficient matrix, and this is the unknown coefficient. This is a data point, and this is residual vectors. So what you want to do is you have to minimize the residual. So you minimize the residual vectors, and you minimize the 2 norm of the residual vectors square. Okay, and this is the coefficient matrix. Okay, that's it.